Hey everybody, welcome to 4-Minute Physics. So in this video I'm going to take you through everything you need to know for half-life, and this is suitable for all GCSE students doing physics and or combined science. Going to do this in 4 minutes or less, so we'll get started. Right, first thing is to recognise that nuclear decay is a random process, so we actually have no idea when any element is going to give out its radiation. So when we have a nuclear material, we're actually holding a nuclear material in our hand, which would be a really careless thing to do, but we wouldn't know when any of those atoms inside that nuclear material are going to actually give out an alpha or a beta particle. It's like rolling a dice. You have no idea when you're going to roll a 6. So how do we make any form of predictions as to how long nuclear radiation is going to last for? Well, we can make these predictions because we use a little bit of maths and a bit of modelling to make sense of this, and this is where this idea of half-life comes in. Now we can measure something from these nuclear materials called activity. And activity is how many particles are actually given out by a nuclear radioactive sample. The term activity is also linked to the term count rate, but count rate is what we can directly measure using a Geiger-Müller tube. The activity is the total amount of particles coming off in all directions. The count rate is just what we can measure using the Geiger-Müller tube itself. But the definitions for half-life, when I do that in the next slide, will work for both the terms activity or count rate. Now, just to kind of bring that together, this is where the term radioactivity kind of comes from, because we're using the word activity. Okay, when we measure activity, we would start off by taking a measurement, and we would notice that over time the activity of the sample would fall. It will never get more than it started with. It will always go down. Now, by observing the change in the activity, we can make some predictions to how long the radioactivity will possibly last for. Now, let's just do a quick definition of half-life. This is important to learn. The half-life is the time it actually takes for the activity of the sample to drop to half the original activity that you measured. Now, you could use the term count rate in this definition instead of activity, and the definition would still be perfectly fine. Now, it's important to learn that definition. Every radioactive material will have different half-life based on the element that it is, and that's a unique property of that element. Okay, let's have a look at some of those examples. In terms of half-life time, we can work this out by measuring the activity to start with of a sample. So let's say we've measured this sample and it's got an activity of 200 becquerels. That's the unit of activity. We then start a stopwatch and we time how long it takes for that to drop to 100 becquerels. We would then stop the clock, and that value of time would be the half-life time. We can also look at this continuing. So we start off with 200 becquerels here, and after one half-life we end up with only 100 becquerels. After another half-life we're now down to 50, which is a quarter of the original amount. After a third half-life we're now down to an eighth of the original amount, which is now only 25 in this example. We can also use graphs to represent this change. Now, if we were to draw a graph, we would need to make sure we know what we're drawing. We always need to make sure we label the axes. So up here we have activity, and along the bottom we have time. In this case I've represented time in minutes, but it could be years, seconds. We would then plot the points. And you can see here how those points, when we connect them together using a trend line, create this curve. This is called a decay curve. And we can work out the half-life by looking at how long it took to get from 200 to 100. And by doing that, we work out the half-life time. In this case, of 3 minutes. That is half-life in a nutshell. I hope that you have understood what I've gone through there in the time we had. We've just done it in under 4 minutes, which isn't bad going at all. In the next video, I'm going to look at a little bit more to summarise what we can use nuclear radioactive materials for, and look a little bit more at the health and safety of how we handle them. Okay, thank you very much for joining me on 4-Minute Physics, and I'll see you next time. Bye for now.